Yep, so welcome everyone to the April 7th SIG Node. It's coming live from space at Don's house. We have a couple items on today's agenda. I think, Ted, you were first up to talk through some issues you were trying to resolve around log rotation. Maybe you want to talk through that?
Yes. Can you hear me?
Yep.
Okay. So in the chat, I pasted a link. After last Tuesday's meeting, I went back to investigating alternative to my proposed solution, and the posted link summarized what I found. So basically, in the log manager, in the GC class, I didn't find immediate data structure, say giving me the data containers ID. So there's an attachment above this particular comment. I used attachment because in the log, I think I spotted a deficiency. So of course, what Lantau suggested is a lot simpler than my PR. However, if you read my comment as posted, what I found is that, let me go to this. So what I found is that in this log symlink, which is in utility class, so we impose basically 255 minus the suffix, which is .log. So 251 characters for the combined length of the full pod name, container name, and container ID. In the current convention, container ID is the last. So if you scroll a little lower, you can see my attempt in the legacy test.go. So if I try to reconstruct the container ID from this particular example, basically it would fail. The assertion would fail. I couldn't. So I look at some clusters at my disposal. The longest such .log symlink was 193. So we're not there yet. However, since I have very limited visibility into the actual deployment in production, yeah, if you read following the code snippet, I see several options. Simplest would be lifting the container ID to the front of the composed symlink file name. But none of them is ideal. So at this meeting, I want to hear the maintainers' take.
Yeah, so Ted, I apologize. I'm not fully up to speed on what the root issue was that was being resolved, but I guess kind of the first question I would have is like, is there a gap in node EDE coverage for this function? And is there a way that we can demonstrate this flake or this race in a node EDE today?
Prior to last Tuesday's meeting, I actually started writing some test. It doesn't look good. Basically, the GC and the log manager are started by kubelet. So I feel a realistic and say not bad looking test would be at the kubelet level. So I have some test code which I can attach to this issue. So in summary, for your question, I think you asked two things. One is, so why there isn't assertion in E2E? Yeah, indeed, there isn't, because there's no assertion with regard to the presence of the symlink. Second question is how to add this. That I'm still trying to figure out. But in the past week, as you can see, I focused on understanding and trying to implement the maintainer's suggestions. So I didn't spend much time on writing the test.
So we talked about last week, and based on what you say, that we can see the potential risk and cause the symlink maybe is not healthy. So we saw that at least theoretically we saw that problem. I don't know what Nantal suggests to you, but I think that we talk about this one and explain from my perspective why I'm concerned, because I look at your PR. And my concern it is because that log, I look at how you implement the log. You have the two, when it is rotate the latest log, and then there's the rename, to rename, and also the and open the file and then rotate the file. And then there's the garbage collection. My concern it is the log contention, because all it is the heavy IO operations and involved here, and I worry about like this log contention. So that's why I suggest that, I guess that based on what you reply, I guess the Nantal also suggests the similar thing. Is there any way we could avoid, make sure, basically it is like what you suggest in your original proposal without log, you see it just like that there's a certain time we make sure the container is removed, and before we do symlink remove, we make sure the container it is died. So what I suggest, just double check is the container died. I think that you try to you try to reply, it is actually there's no way for you in the log content. Maybe I haven't looked at your latest change yet, but based on what you just say, that after that one in the garbage collection or with log rotation, you don't have the data about the container status, right? So you just don't know that which container, a container ID, or like you cannot through that container ID and get the container status. So you don't know that it is died or not. Maybe I misunderstand you, but that's my concern last time, because I read your initial proposal, and there are too many disk IO operations involved. That's my concern. Yeah.
Yeah. So to answer your question, the kill container is not isolated to the GC class. So yeah, so if it's isolated, we can maintain some data structure, but say toward the end of this particular comment, which is a bit long. So I mentioned that, say, suppose we maintain this data structure is in either GC or the reference manager. However, we need to garbage collect this data structure as well, right? So let's say we have a long running pod, say running for, if not a year, let's say a month or something. And then containers come and go, right? So of course, at any particular moment, we can determine in the recent past which containers were gone, right? However, we need to garbage collect this data structure as well. Actually, I think you or Lantal haven't read my initial proposal. My initial proposal is this. So the GC is every minute, right? So at minute 1 or 0, we take a look. And so if some particular symlink is deemed to be unhealthy, we just record it. At the next minute, n+1, we check again. If this symlink file name is still can still be considered unhealthy, then we remove it. So the rationale is that so there could be subsequent rotation of the log. However, the rotation shouldn't happen per minute. At reasonable default for max size, etc. I don't think the log would be rotated every minute, basically minute 0 and minute 1. But I don't know if McNaughton is here. It seems McNaughton and Lantal, yeah, and I think neither of them is here. So Matt McNaughton took a look at my very first proposal and he didn't like it. So I switched to this additional lock. As you said, of course, when one participant is holding the lock, of course, the other participant will be delayed a little bit. My feeling is just that, so we have several options. Basically, the very first, meaning delayed the symlink removal by one minute. So the additional, this structure is very simple. Second is the introduction of the lock. And third one, the simplest I can think of is to lift the container ID to the beginning or earlier part of the symlink composite file name. Yeah, and more. If you read this, my comment, yeah. Though I haven't implemented all the alternatives I suggested, because some alternative, especially toward the end of the comment, I think is the complexity is on par or even more complex to what I'm presenting now. If we have another use case where the GC class needs to know the mapping between container name and the container ID with regard to that containers, then probably that can be justified.
I don't have like a general concern about the lock. I just have the concern when the last week you came here, because you introduced the lock at really not at the final ground level. So you basically there's the lock and then the lock entire of the rotation lattice of the lock, and then there's the some like a highway. There's the some disk IO, and I cannot say like a highway because it's based on the resource usage on that node. And then there's another one, it is on the garbage collection. So that's basically, I think it's related to highway because we need to remove those containers. So that's my concern. But today I look at your code, I saw your update reply to Nantal. And I kind of understand what you came from, because I do suggest to avoid that problem, to make that the same link is not valid, the same link. The problem, like the check the container. I can say the through your current way, but maybe Nantal have some other idea, or you have some that. But I just want to say that my concern is mostly is from the way in your current proposal, the PR, and the way how you are using the lock. It's not negative to the lock in general. So we
I
may,
guess my
yeah.
first concern, if that's okay, Donna, is that we don't have a way of measuring how often this happens. So like I was just trying to work back, and it looks like the original reporter gave a bash script to try to reproduce. What I'm wondering is, like, before trying to settle on a solution, should we get a node EDE that does the reproducer? And if we see that node EDE is still flaking, then we go and do a resolution. If it's not flaking, I don't even know if we actually have the problem. But it seems like the first thing we should do is have the node EDE that reproduces this reproducer. And we have one node EDE for node log test that basically says, I run a pod, I'll try to get the container logs, but it's definitely not stressing the use case. And so maybe just stressing the use case is the first step, Ted, I would recommend, because like, then we can look at saying, hey, I reran this stressor 20 times and the kubelet was still okay with the change proposed. But like, I don't feel like a deep rush to fixing it without understanding the real world number of how often this is happening, or a clear reproducer that's not from 2017. If there's a more recent reproducer.
Yeah, I like Derek's proposal.
Yeah, I also like I like Random Lou's comment on it that, you know, we should probably be able to check to see if the container is running before we remove the symlink to fix the issue. I think he's right. It looks like the author just didn't have access to that information. We should be able to get that off of Run C or just via C. So yeah, I think we can fix this.
Yes.
We just have to help them out a little bit more, I think. without introducing a new lock.
Yes. I saw Nantao joined. Maybe Nantao want to say.
Oh, there it is. Cool.
Yeah, I just plan to comment on the issue. I feel like actually in the GC, in the container GC, that component will already have a function to list all the containers, and we just need to reuse that.
Yeah.
Yeah, either list all the running one or list all the containers, and then we just need to check whether the container corresponds to that same link is there and whether it's running, and decide whether to remove it or not. Yeah, I think it should be doable. I will comment on the issue and carry this offline with you.
Yeah. So yeah, if you can take a closer look and point what I missed, that would be nice. However, I'm thinking if prior to the removal of unhealthy symlink, we list the live containers, wasn't that basically he exposed some other kind of risk? After the listing, after we obtained the listing of the live containers, because it's dynamic, right? So we don't know how long, say, any particular or some of the live containers would continue to live. Of course, it's very close meaning the removal of symlink decision will be made, say, very shortly after. However, of course, if you list that container, I think, Lantao, maybe you, I don't know if I misunderstood your, so we can list containers. However, the question is, so we have a symlink, right? Say full pod name, dash container name, dash part of the container ID. We cannot just use the prefix of the container ID to match against either dead or live containers. That's a part of the confusion I wanted to express in my comment. So please allow me to come back to Don's comment 1 minute ago. So I look at my PR, the scope of this particular new lock, symlink lock, can be moved inside the for loop. I will update my PR after this meeting. Yeah.
Okay, so can we step back a little bit? I really like what Derek suggests, and the original issue file, I think that it's in the 2017, if I remember correctly, it's a while back. And based on your description, I totally understand there's the potential, theoretically there's the potential, there's the risk. And so can we have the E2E test to reproduce the problem first, and then we talk about the solution second, and I will need you and Nantao to talk offline, and if there's you can access the container status through the container garbage collection. I also understand you could make that to the log final grant, because that's my concern last week. So if we do have this problem and we have the E2E, then that E2E can help us to validate any solution. And no matter it's locking or it is other way. So I think that's maybe is the good approach. Is that okay?
I think my concern or my, with regard to E2E is that the GC and the log rotation, to my understanding, are independent, right? So given, because the end-to-end is one, of course, we are going to add more E2E tests. However, they only exercise a certain type of workload, right? Let's say, let's look at the simplest.
We're not discussing cluster EDE, we're discussing the node EDE suite. And I guess what I'm trying to do is, one, like, really appreciate your passion to try to make the kubelet better, but I'm also trying to balance that with the passion to make sure it doesn't regress. And so having the test first to demonstrate the problem, I think is really a way I'd love to pair both our passions together, if that makes sense. So even coming back and saying, hey, this is what I looked at for the existing node logs test in Node EDE suite, and these are the gaps I see in testing of this function. And this is the PR to address the said gaps. And maybe that gap that was added will call out the actual end user report. I think that'd be the ideal path forward, right? Because then we know that we're not regressing and we know that we're testing what our users hit. And in general, any opportunity I have to try to get more assistance in adding more Node EDEs, I think Dawn and I would appreciate the help.
Definitely, yeah.
All right, yeah, we can continue our discussion offline.
Thank you, Ted, for this one.
Thank you.
Okay, I think next up was the memory manager kept.
Yes. Hello, everyone. Let me share my screen. Can I share my screen? Because I have a communicate that has disabled participant screen sharing.
I'm sorry, you're saying you're not able to share your screen?
Yes, I'm not able. I have communicate that has disabled participant screen sharing.
Yeah, let me see. I don't know, Dawn, if you can click his name and give him powers.
Let me see. Yeah, I can.
Okay.
Allow. What I should do for this one? Allow the.
I think by default, only hosts can share their screen. You have to enable all participants to share their screen.
But I don't know where. And also today is, I thought Derek, you are the one start today's meeting.
It shows up as we're both co-hosts. So I see an option here to ask to start video, but I don't know what that will do when I click it.
Okay, how about I make you co-host I make you co-host for this one. So now maybe you can.
Okay.
You are the co-host now. Yes.
I'll try.
Yeah, try.
Okay. It's working.
We are learning this new interface UI. Perfect.
Okay.
We can see.
Okay, so do you see, right?
We can see. Perfect.
Okay, great. And so for everyone that don't know, my name is Krzysztof Wiatrzyk, and I want to give you a brief presentation regarding enhancements toward high performance packet processing. And the purpose of this presentation is to give you a clear insight what we want to do, because some related documents and PRs will show up on the next meetings as we are working on these enhancements. So let's move to the agenda. Okay. So first, I would like to tell what is the purpose, what is the goal of these enhancements. Later, little about background motivation, and this is based on 5G and DPDK example, and what is required by DPDK to run with Kubernetes in the effective way, what limitation and challenges this brings to us, and what changes we propose to be done, and what is the current ongoing work. Okay, let's get started. The objective of proposed changes is to improve Kubernetes in supporting performance-intensive, high-throughput network applications. And actually, there are several use cases of that. For example, containerized 5G deployments have strict requirements that has to be met about speed and latency. Also, MEC, which stands for Multi-Access Edge Computing, has to deliver low latency access to edge applications, and these improvements can assure that or improve it at least. And these improvements can also be useful for current or new implementations in the future about IoT or AR. Okay, a little about background. As 5G networks rolls out, telecom companies try to shift from the VNF to the CNF, which basically mean that packet processing won't be done in the virtual machines and will be done in the containerized environments. So for example, UPF, which is a key component of 5G, must have been ensured effective packet processing to meet those requirements I mentioned earlier. And how to do this on the application side, the answer here is the DPDK. And DPDK, which stands for Data Plane Development Kit, it is a framework. Basically, it allows us to bypass the kernel network stack and manage the packet processing quicker in the user space. To do this, we have to meet some requirements, and this is it. First one, CPU pinning, which would eliminate context switching overhead. In Kubernetes, we have CPU manager static policy, which supports CPU pinning, so this can be done. Page locks, as Kubernetes doesn't allow swapping, so this is also done. Huge pages to reduce the memory access time, and Kubernetes supports huge pages, and there are improvements in this also in this area. Version 1.18 will I think it actually offers the isolation of huge pages among containers feature. And yeah, SRIOV to bypass a virtual switch and to reduce latency. And there is an Intel SRIOV device plugin that supports that in Kubernetes. So as you see, those requirements can be met. And the last requirement that we mostly focused about is the NUMA alignment of resources, to align all of the compute resources from only single NUMA node. This is to prevent inter-NUMA communication and drops in the performance on multi-socket machines. In Kubernetes, we have topology manager that supports NUMA alignment of CPUs, CPU pinning, and PCI devices, but there is no component about NUMA alignment of memory. So we have some limitations and challenges regarding this. As I mentioned, there's no component that manages the NUMA alignment for the memory, and this includes huge pages. Topology manager coordinates the assignment of resources at the container level. There is no possibility to assign the resources at the pod level. And also CPU manager doesn't support NUMA aware CPU sharing. I will tell you based on an example why this is a problem. So now let's go briefly through those challenges. First challenge is to run the DPDK applications in a single pod in the effective way. And in the effective way means that we want to have the fast access to the resources, and this can be done by aligning all of the compute resources from single NUMA node. So as I mentioned earlier, there is possibility to do this for CPUs, for PCI devices, including NIC, and there is no way to do this for the memory. So the solution here that we propose is a new component that provides topology hints, which indicate at what NUMA nodes the adequate amount of memory or huge pages for a container is available. The second challenge is to run multiple interconnected DPDK applications in a single pod, that those applications can communicate with each other through a NIC or a shared memory. So the issue here would be if one of those two containers would have assigned resources from the other NUMA node. Then if they would like to communicate.
I apologize. Yes. So between challenge A and challenge B, I don't know if everyone is as aware of the space as you are here, but like, why do you run multiple interconnected DPDK applications in a single pod? Like, why is that a requirement?
Okay, so example could be, okay, maybe not DPDK, but some applications that DPDK must to communicate with through the memory. So for example, it would be some database or something like that. And if they would communicate through the memory, and the resources for the second container would be from the second NUMA node, they would have to use those QPI or UPI channel that was between the sockets.
Okay, so it's not necessarily two DBTK containers, but a DBTK app running with some other helper container.
Yeah, I think I'm not sure what is the purpose of two DBTKs right now, but we can ask that to my colleague in the document. But I'm aware of the situations like that. That two containers may have to communicate with each other in through the memory or NICs. And the third challenge that is connected with a little bit with the previous challenge is to run the DPDK application alongside the containers supporting the DPDK app and running on the shared CPU pool. So the situation is similar to the challenge B, but this supporting container requires only a fraction of CPU, but it's still in the guaranteed quality of service class. And the current behavior of CPU manager static policy would be that this supporting container, would receive CPUs from both NUMA nodes, shared CPUs from both NUMA nodes. And the solution that we propose here is to implement a new CPU policy that would support NUMA-aware CPU sharing, which means that this supporting container would receive shared CPUs from only one NUMA node. And that would resolve the problem. Okay, so
I thought on
yeah.
that last point, I don't know if Kevin or Victor are here, but I thought we were working towards making it not a requirement that the sidecar container needed to request integral CPU values, but that the work in topology manager and CPU manager could be extended to burstable clause tiers. Am I not recalling those discussions well? I don't know if Kevin or Victor or Connor or anybody else who was working in the space are here to speak to it.
Okay.
Derek, it's a bit different problem. So the current situation in the CPU policy inside the CPU manager is such what it has only one shared pool, and everything what is not exclusive is part of a shared pool. So if you have multi-socket system, the shared pool will be covering always all the sockets, all the NUMA nodes.
Yes.
So the situation to solve it will be to have like multiple shared pools, and that's not possible in current static policy. So it's require new policies.
Yes, that's right.
I'm being slow. I'm sorry, this is complicated. So if I have a multi-NUMA node and I have the NUMA topology manager enabled and I have CPU manager on, and I had is the issue here that you don't want to use the strict policy?
No, it's different scenarios. So in case of guaranteed class, the static policy just slice one CPU or integer amount of CPUs out of a shared pool and pin it according to the topology. But the rest of the shared pool is like the rest of CPUs. So unless you exclusively have a CPU, you will have a pool which will be spawning.
Oh, I'm sorry. Okay, so you want per NUMA node shared pools.
Yes, this is the idea. This supporting container want to have CPUs only from this NUMA node and not shared CPUs from both NUMA nodes.
So what happens as more containers get scheduled to that node that shrinks the shared pool to 0?
And for this would be some kind of safety zones proposed. And we have proposals written down about this, and we will be presenting them in the next meetings.
Okay.
Okay.
Okay, I understand the problem. The struggle I have is like when you combine the solutions to all of these 10 problems, understanding if all 10 problems are actually solved together is non-trivial. So thanks for letting me ask questions.
Sure, that's understandable. In the SIG Node document, there is also document that is describing these proposals, and in this document we will be putting this detailed proposals that would explain this problems and solutions more in detail. Okay. So this is those 3 changes that we propose that are regarding these 3 challenges. The first one is memory manager, a new component, which goal is to identify adequate amount of memory or huge pages at NUMA nodes and provide topology hints to the topology manager, support the alignment of memory and huge pages to the same NUMA node, and to guarantee that the memory access is done at the same NUMA node where CPUs are assigned. This basically depends also on CPU policy and topology policy, but this is the general goal of this.
Is my recollection correct that this was the only proposal that desired a change to the pod spec itself?
Pod spec, I think there is also a topology manager policy that would require here a pod spec change.
At least for POC, we don't need really any change on the pod spec. We don't want to introduce any API change or something like this. Like we want to introduce additional kubelet flags for memory manager policy, but currently no additional flags.
Oh yeah, that's right. Yeah.
Okay. Okay.
Yeah, I will go to the topology manager explain here. The second change, let me get back. This document was shared with SIG Node last week, and slides are still be done, and this will be more in detail presented in the next meetings. New CPU policy that would limit those sharing CPUs to local NUMA nodes, so we would have a couple of sharing groups rather than one that it is currently in the static policy. It would also support the exclusive CPU assignments, and this is the same behavior as static policy does right now. And there is the proposal document. It is still in work in progress, and slides will be made. And the new topology manager policy, which goals is to support the binding of pods which have different topology requirements to the same node. And this goal, which would actually require a pod spec change. In the proposal, there will be more details about that. And the second goal is to support pod level resource alignments for all containers in a pod to the same NUMA node. So if you have 2 containers, we can tell that we want to align them to only one NUMA node. And the proposal is still in progress. And to summarize that, we will generally make changes to those 3 components, and memory manager is a new component. And actually, that's all. If you have any questions, I encourage to ask right now or in the document as comments, and me and my colleagues can address it.
Did anyone think about how this is going to affect about the pod allocation, pod scheduling? I think we touched base a little bit. We ran out of time last week. And is it possible you have those, no matter is the topology manager pod binding on the same NUMA node, and also like the per, so you also suggest like the per NUMA node, the CPU pool, sharing pool, and all those kind of things actually end up could be like the conflict between scheduling decision and the Kubernetes decision, right? The Kubernetes could be say, oh, based on all your requirement, all your new policy, and I cannot really run that pod. I cannot really satisfy all your requirements here. But the scheduler don't know. So have you ever think about that one here?
Yeah, but we already have this kind of conflict with device manager and CPU manager. Like if topology manager receives a request that he has devices that requested by the pod only on the NUMA node 1, and he has CPUs, static CPUs available on the NUMA node 2. So we already have this kind of problem.
But this makes that worse.
Yeah, I know.
Yes.
I was telling every time the CPU manager and all those kind of things, I'm have the concern. I think I keep repeat this problem.
It's true. Like at Reddit, we already have a number of people who's trying to think how we can solve it on the scheduling level, like scheduler extension or something like this. We want to create some general approach that will be suitable for the Kubernetes, for the community, because again, like most proposals will need some change on the node status section, like node API. Like you need to provide somewhere the information about NUMA topology somehow. I don't know. So yeah, we have like number of people who trying to solve this problem and to provide some cap to the Kubernetes, but like I don't have any additional information currently regarding the scheduling.
Well, last week actually we talked about that, and besides changing the node status and well, making the scheduler aware of all these topology resources, there is another possibility is just for node to say like, sorry, I have a problem with this pod, I cannot run it. And it's not a whole problem of a node, it's just problem for this particular pod. Scheduler, please reconsider. This kind of error right now is missing. I think I saw somewhere discussion about to use the scheduler for this, like just as a quick walk around, but I don't think I've seen the prototype for it.
I just wanted to say that we are aware of it, and so the approach right now is to minimize it and then think about some changes to the scheduler or another way to achieve this, because like it was said, it is currently the problem also with CPU manager static policy. Yeah, we will make it worse, but we will bring new enhancements and possibilities, those changes.
So can I ask another macro question, if that's okay? You enumerated 3 challenges. I'm trying to draw a distinction between good enough and perfection. What would be your view on, are all 3 needed to be making Kube good enough for this use case? Or is it really all 3, let it be perfect, but there's some compromise to complexity and good enough that we could all think through?
If I correctly understand question, what would be the perfect way to modify the kubelet to achieve that?
It's more like there's no shortage of use cases Kubernetes could be tasked to go explore and optimize around. And what I'm wondering is if what you're presenting here is, in your view, minimal to Kubernetes supporting that use case, or like what is challenge A, B, and C all tied up in your minimum viable product, or is there a particular challenge that's more important than the other to that MVP?
Okay, so those challenges are actually regarding improvement the performance of the DPDK, and they come from this side. and this is actually maybe not minimal, but so let me get back. This challenges that I presented. So it is start. It is the. I'm not sure what would be the correct answer here, because I'm not sure still what would be the ideal way. This is the way that we decided to go, and I don't think there is ideal way.
Yeah, I mean, I appreciate that honesty, honestly. Like, I think we're all trying to figure out the ideal, and so I was just trying to probe your perspective.
Okay.
I think A makes sense to me. I feel like B and C are variations on the same use case, is my understanding of what was presented here.
Similar, I would say.
From like a kube perspective, right? It's like
Okay.
I have 2 containers in a pod versus 1 container in a pod.
Okay, sure.
And so the other thing I'm curious about is, like, once these pods are in production and running, like, what is the production interaction with these pods? Like, are people doing backups of some database that they're running in that sidecar using kube control exec? Like, where does the next level of problems exist for how people are doing something in that supporting container or not? You know what I mean? Because that's what I'm trying to figure out, is like, where do we reach a point of
okay, honestly I understand what you mean, but I'm not aware of that right now. I think
So
that my colleagues could tell more about this, but one is in Korea and he's sleeping, and the second one is currently on PTO.
So from a prioritization standpoint, of the 3 proposals that you're interested in pushing, which one would you want to prioritize focus on first?
This is a difficult question. And I think that the most important is here the memory manager. So it would be the first challenge. And actually the cap was done for that a while ago. But if it could be discussed also on the document, it would be great. To ask my colleague, and actually he's acting in this area, and this is the Byung-gun Chan. Okay.
So I know the experience of going through the topology manager work, like, we don't have a simple community environment to do multi-NUMA node testing. So I know Victor and Kevin wrote a bunch of tests that only run when on multi-NUMA nodes. And then I can say at Red Hat, or I'm sure at NVIDIA, we're running those tests to make sure they don't regress. Do you know what would be expected from the community side to maybe better support upstream testing of some of these things? And is that something that you could help facilitate?
I don't know.
In general, it's possible to configure NUMA nodes like on the virtual machines level. On the virtual machines level, I'm not sure if Google Cloud Engine supports this kind of configuration, but if it supports like configuring virtual NUMA nodes, why not? Like, you can configure it, run cluster on top of the virtual machine, and test, like, run multi-NUMA test on it. So it shouldn't be too hard. Like, I created virtual machine on my local laptop and just run a kind cluster on it and tested memory manager POC on top of it. So yeah,
So the first thing you said there like bugged me because then you're running kubelet in a container, and that's not actually how you're probably going to be running here, and not actually really supported by the SIG. So I only bring this up because of the experience in 118 and doing topology manager. I know I spent a lot of time with Victor and Kevin trying to get tests passing, and the more we get pushed to do this scenarios, like the more it'd be useful to have infrastructure that is shared that we can all verify testing against. And so basically there's a cost to this, right? One is the code and complexity cost, and then the other one is just how do we get good test signal? And maybe the follow-up I could ask is like, if you could sync up with maybe Kevin or Victor and brainstorm on what we could do here better, that would be appreciated.
Sure, it can. I happily will help with it. Like, probably I will need some help of someone who is familiar with the Kubernetes infrastructure, like who is one responsible to configure all these Google Cloud instances and stuff like this.
Yeah, or you could run a prototypical 5G node somewhere remotely and like report the test results back. And so that's basically what I think Victor had been looking at on our side. And then, and so that was like topology manager with SRIOV. And then I think Kevin on his side was topology manager with GPUs. And what I'm wondering is like, if we can have a reference 5G hardware type of infrastructure available to the SIG, it would be easier for us to all collaborate better is all I'm trying to think through. Because right now it seems a little piecemeal.
Okay, sure. This is understandable.
I have some comment. So based on your slides, you just show the proposed change ongoing work. And
Yeah.
I think you categorize at the 3 different pieces, and the memory management, CPU policy, and the topology management policy.
Yes.
Actually, they are all related to each other. I just want to say, like, for example, your CPU, like that you want to suggest the per NUMA CPU sharing pool. Actually, that's like no matter how you are going to pin CPU, that's the hint for kernel. Basically, that's a hint to kernel how to allocate of the memory. And so a lot of those kind of things, actually, you cannot really separate in a separate way. So that's why I like the Derek's suggestion. Let's figure out how we are really can have the test infrastructure and approve those proposals and validate those proposals. And we need really thinking about, if you really want to support, I think that even like the couple years ago when we first started the Kubernetes, the QoS, all those memory management, there's the people in the community have the demanding to support the high performance workload. And I remember that time I keep mentioning that we cannot really separate those things. CPU, memory, NUMA all have to take together and look into this one as a whole. And so this is just my first reaction when I saw the proposal. And a lot of your challenge, you have the 3, like I agree with the Derek, and then top 1 challenge maybe is the one the first one we should be focused on. And a lot of, but my also problem it is those challenge earlier I mentioned that it's not just related to the scheduler. So we have the potential challenge scheduler may be just controversial, make the controversial decision about Kubernetes, not just that, and also deployment. And even we are do well good job, you have like the people deploy some workload. Obviously for your use cases, maybe my concern is we add those features in and the people don't know how to use in those features because it's complex the feature. And even scheduler don't know how to place the jobs, right? So place the part if we don't solve that problem. The worst part it is the people have like the, in your cases, Sansan, I looks like the, based on your first slides, maybe it is okay, you could do something. But my concern it is because Kubernetes is the common infrastructure for many people. So the random customer may is thinking about they have, once we have this kind of feature, so they may end up to don't have like the initially don't have like the new map typology exposed to those kind of things, and they already have like the running part, but those running part also have the different performance requirements, all those kind of things, and then later they schedule new part which have some like the high performance requirements and application on the node. So then they cause the problem. They said, oh, this feature is not so. So I think that we start need to really thinking about from the Kubernetes level, how we're going to manage those workload. Obviously, most code will be, most of those scheduling and the collaboration, all those kind of things will be on the node side because it is how we interact with the kernel. But we need to figure out to focus on the API, Kubernetes API level too. My concern, we used to talk about in SIG Node and resource management work group, we talk about resource class, and that go nowhere. So my concern it is without expose those kind of problem, we actually add complexity to the people using Kubernetes, but not really solve their problem.
Okay.
And, because I have the many years experience with Borg before this project. All you proposed, I saw those kind of problems. We solved those problems, but one top mistake we made it is just quick dirty at node level. Because I was working on the node level, and I think that's fancy projects to working on, and we just solve those problems. But at the end, actually at the class level management, that's really painful. And so we have to go through all the trouble and redo a lot of work. That's my concern. Just want to share with here. And so it is solvable problem, but once you're thinking about like the thousands workload and scheduled at to the cluster, and they have the different requirement, unless you have the unified of the workload. From your use cases, I can see that your workload, is quite unified, but not all the customers have that one. So this is why like the people really, I only care about my workload. So that's why I just only care about how I solve this problem on the node, because all is the same. So I can do the very easy. But if you have like the heterogeneous of the workload, and you want to manage those kind of things, this is basically is really painful. So we need to solve at the Kubernetes level how to do those application and the release locations. Yeah.
Okay, thank you. Those were very good concerns, and we'll have them in mind. Thank you.
Thanks.
I have a question about memory management.
Okay.
So I read a proposal and have understood correctly that it forces a single NUMA node assignment. So in my understanding, it's actually not a job of hint provider to like apply restrictions like that. It's a job of topology manager to actually get the like all possible variants and apply topology policy to those, and like do understand the concern here. So, in my understanding,
yeah,
memory manager should provide all possible combinations like hints, not just for the single NUMA node, but the like for the cross NUMA as well. And the
Okay.
topology manager work is to actually apply its policy. If it's single NUMA, then okay, so it will filter out all the rest. It's not, then like this would make the solution more generic in my opinion, because workloads are different. So not all of them actually require to be run on the single NUMA node. And like with this approach, I like to actually provide the hints and let topology manager to decide the configuration based on its policy. It would be more generic. So
Okay.
did you see like some problems with this, or you just didn't consider this?
The problem is that you cannot know where the container will really reserve the memory on which NUMA node. Like you will specify NUMA node 0, 1, and like you don't know any information about where this memory will be really allocated. So you will need to reserve the same amount of memory also on NUMA node 0 and also on NUMA node like 1. We hope once we will some proposal for the scheduling, it will be solved on the schedule level and not on the node level. And it mostly why currently we only consider the single NUMA node policy. Like currently we just return topology hints with single NUMA nodes. Like
which will work incorrectly in case if you have in CPU, well, in BIOS enabled the features of subNUMA clustering. So practically you will have per socket 2 NUMA nodes, which is performance-wise is very close to each other, but you practically like halves your memory available for your containers to decide.
I would propose to discuss it further offline, maybe, because we are over time now. But that's actually the main thing that concerns me in this proposal. I also read CAP, and it's kind of provides the same idea, basically. So in my opinion, we should come up with something more generic that not only covers like one use case, like single NUMA assignment, but like more than that.
Yeah. Yeah, let's carry on the discussing and also welcome next week and continue discuss if there's So I think we already
Yeah, Dawn needs to get a new spaceship in outer space. But yeah, thanks all for participating today, and a big thank you to both Ted and I apologize, I do not want to mispronounce your name. The team from Samsung for talking through their proposals, and I'll upload the recording shortly. And I will talk to you all on Slack or in our meeting next week. Have a great time. Bye, guys.
Thank you. Bye.
Everyone.
thank you, guys.
you.
Bye.